Hello everyone, welcome back to yet another video from my channel Interactive Education, running for the best education possible from the student to the student for a better experience. And today I am going to take up a very good question I found, and someone commented this question on one of my videos, so I'm going to take this question up in a video. And that is, we need to prove that the tangent drawn at the midpoint of an arc of a circle is parallel to the chord joining the endpoints of the arc. So this is a good question because it involves some application from last year's mathematics as well. So let's first of all try to analyze this question. They've told us that there's some circle. Okay, there is some circle which they have given to us. Okay, and the circle has a center. Now they are saying that we are taking some arc, an arc on the circle. So any arc, suppose this is A and this is B. So AB is my arc, right? Arc is basically a part of the circle between 2 points. So A and B is an arc, AB is an arc. Now this arc has a midpoint drawn at the midpoint of an arc. So basically, let's take a midpoint of this arc, suppose C. And this midpoint is such that AC arc length is equal to CB arc length. AC arc is equal to CB arc. Now, we are joining the chord between joining the endpoints of the arc. So basically, AB will be a chord, and this chord joins the endpoints of the arc, right? We need to prove that the tangent drawn through the midpoint of this arc, so tangent drawn through C. So if I draw a tangent through C, that is, this is the tangent through C, I need to prove that, or let me draw it properly now. Suppose I draw a tangent through C, I need to prove that this tangent which is through C, this tangent, suppose PQ, which I am drawing through C, needs to be parallel to AB. That's what I need to prove. This PQ tangent which I am drawing through C is parallel to AB. That's what I need to prove, right? So let's prove that. That's my question. So basically the proof, what do we need to prove? To prove, the thing which we require to prove is that AB is parallel to PQ. Right? So how do we prove that? First of all, you need to do some construction. Right? And that construction is going to be, you're going to join OC. So first of all, join OC. We need to join OC. That's imperative. Before that you can't do anything. Okay, so let me draw it properly. So OC is joined. Now I joined OC, and let me draw it properly. Sorry. Now I joined OC. OC is joined. Now after we join OC, the next thing which we need to do is, first thing you can particularly mark that this is 90 without doubt, right? So I can say join OC. After that, write down the proof. Now I can say the first thing without doubt that OC will be perpendicular to PQ, right? Because radius is perpendicular to the tangent at the point of contact, right? Radius is perpendicular to tangent at the point of contact, right? That's the rule. The next thing which you can see here, or the next thing which you should add in the construction itself, join OC, OA, OB and AB. So you're supposed to join AB, or AB is already joined. Now you need to join AO and OB, or OA and OB. So you join OA and OB as well. Now you know that AC and CB arcs are equal, right? Right? We know that. And mark this as 1, okay? Mark this equation, which we found here, this equation as equation 1. Now we know that AC arc is going to be equal to CB arc, right? Because C is the midpoint of AB, right? C is the midpoint of AB arc. Hence, AC arc is going to be equal to CB arc. Therefore, from 9th standard we have learned this, that equal arcs subtend equal angles at the center. Equal arcs subtend equal angles at the center. Equal arcs or equal chords, both are okay. Equal arcs subtend equal angles at the center. Therefore, I can say angle AOC is going to be equal to angle BOC because equal arcs subtend equal angles at the center. Okay, so that's what you need to use here. That's the idea you need to get here, right? Now, consider triangle AO. Suppose let us assume that this point is some D. Okay, at the point at which OC meets AB, let's mark that as D. So in triangle AOD and triangle BOD, in triangle AOD and triangle BOD, I can say AO equal to BO. Obviously, both are radii of the same circle. The second thing is that angle AOD is equal to angle BOD because I got it from equation 2. Suppose this is equation 2. So from equation 2, AOC equal to BOC. Therefore, AOD will also be equal to BOD from, and this you can write, from 2, sorry. Right? AOD equal to BOD. And lastly, OD equal to OD because it's a common side. Right? So we got these. So we got this angle equal to this angle. We got this equal to this. And we got this equal to, not this. This equal, common. Therefore, I can say triangle AOD is congruent to triangle BOD by SAS congruence. SAS congruence. So therefore, by CPCT, what can we say? Can we say angle ADO is equal to angle BDO? Right? Angle ADO equal to angle BDO. Right? That's obvious. This angle will be equal to this angle. And you know that the sum of both angles is 180 degrees. Let this be equal to 90 degrees. Right? I'm just doing it directly, but you know ADO equal to BDO, and the sum of ADO and BDO is going to be 180 degrees because it's a straight line. Therefore, ADO equal to BDO equal to 90 degrees. So, take this as equation 3. Now, this angle is 90. They are saying OC perpendicular to PQ. So, therefore, if ADO equal to BDO equal to 90, this implies something. This implies that if these two angles are 90, can I say OD is perpendicular to AB? OD is perpendicular to AB. OD is perpendicular to AB, right? You can say that directly. OD is going to be perpendicular to AB because both angles are 90. So, both are 90, they are perpendicular to AB. Therefore, I can say angle ODB equal to angle OCQ. ODB, this angle, equal to OCQ, this angle. These two angles are both 90 degrees. ODB equal to OCB equal to 90 degrees. Now, can you say beta that this is equal to this and these two are corresponding angles of these two lines? These two are corresponding angles of these two lines. Now, since the corresponding angles of two lines are equal, we can say that AB is perpendicular to PQ. Therefore, as corresponding angles are equal, I can say AB is parallel to PQ. Because if you take any two random parallel lines, you know that the transversal which passes through them makes two angles, this angle and this angle, which have to be equal, and these two angles are called corresponding angles. So the corresponding angles between any two lines, suppose these two lines are there, they are not parallel, but still they form two angles. These two are also called corresponding lines. But if these two corresponding angles are equal, they have to be parallel lines. Therefore, since this equal to this, they have to be parallel lines. Right? So I hope that's absolutely clear. This is how we prove that AB is parallel to PQ, and we proved that the tangent through the midpoint of the arc of a circle is parallel to the chord joining the endpoints of the circle. That is, AB is parallel to PQ. Right? So I hope that's absolutely clear. It's a very, very good question. So thank you, Samarth, who has asked me this question. It was asked by Samarth. So thank you very much. And with this, we conclude this video on this question as a part of circles. I hope it gave you a practice of the theorem and of a previous year concept. So please remember, board can ask you this model of questions as well. Thank you very much. Goodbye. Stay healthy, stay smart, and do keep studying. Bye-bye.